Alright, these are the last two in here. There is something called an angle addition postulate, and we need to be able to construct an angle as well. Okay, an angle bisector is a ray that divides an angle into two angles that both have the same measure. Alright, in the figure, looks like this one over here, this figure, right? Ray BD, ray BD bisects ABC so that angle ABD is the same as DBC. These angles here are the same. And we can put these little kind of arcs in there, and as long as these both had one, now they both have two because I put another, that means the angles are the same. It's another way of marking angles congruent other than just tick marks like that. Alright, then there's a step. I'm gonna actually show you this one up here. If you have two angles such as, alright, PQS and what we got, SQR, we can say that the big angle PQR is equal to the two small angles PQS and SQR added together. So those are our notes, and here is how you do it. So there's two steps. You should look at this. Keep this. I'm going to turn it over, but you should look at this, right? Place your compass at the vertex and make an arc. Then all you do is you place the point of the compass at either P or Q and draw an arc out here. And then you go to the one you didn't use and draw another one. And then this point is where you draw through and you've bisected the angle. Alright, these two are half. So I'm going to show you. I'm going to do it one step. I'm going to walk you through it right here. Alright, so here it is. Alright, so it doesn't even matter the arc. It should be large enough that it could bisect in the middle, and maybe something like this. So I place it at the point of M. Alright, and I draw an arc. And I don't even really have to adjust this. Alright, unless it doesn't meet in the middle. Then I go up to this first intersecting point and I draw an arc like this. Then I go up to the other point over here and I draw an arc, and wherever they cross, right, wherever they cross, if I put my pencil there like this and draw to this angle and this angle are congruent. You've bisected. So let's do it again. Alright. You start at the vertex and draw one large arc that intersects both rays. So here is one that intersects both rays, right? You move your point to one ray. If you have to adjust it so they cross, do so. You draw an arc. You move it to the other intersection of the other ray and draw an arc, and they should cross. They've crossed. And wherever that is, you connect it. So I'm going to draw straight through here. Alright, I'm going to do it again from here. So I'm going to do one more, maybe two more. I go to the vertex and I draw an arc that goes through both rays, like this. Notice I didn't even complete it, I just got the edges. I go over here, draw another arc. Might have to expand it if it doesn't reach, but these are going to reach just fine. Go over here, draw another arc, and where they cross is where I draw through to the vertex. Let's make sure it's a ray. Let's mark the angles congruent. Alright. Do the same thing one more time here. I'm going to draw an arc. Move to the first one. Draw an arc. Move up here to the second one. Draw an arc. Look, I messed up. They didn't actually cross. I'm going to go back to the first one. Make it cross. You're right. And there they are, bisected and marked it. So these guys right here say this. It says that HIW is an unknown. So I don't know what that is. It says WIJ is 10x. Right? HIW, or HIJ, this entire angle here, is 145. And HIW is 2x plus 13. Alright, so I know that this angle of 10x plus this angle of 2x plus 13 is equal to 145. That gives me 12x plus 13 equals 145. If I subtract 13, I get 12x equals 100 and, what is that, 32? If I divide by 12, I get x equals 11. And it wants me to find HIW. So HIW is 2x plus 13. So angle HIW equals 2 times 11 plus 13. So angle HIW is equal to 22, 32, 35 degrees. Like that. Let's do another one. Alright. So let's see. FCD is x plus 41. BC FCD, did I do that right? FC, oh, I did that wrong. I put it on the wrong side. This goes down here. X plus 41. BCF is x plus 78, and the entire thing is 95. So I could say these small angles, x plus 78, plus the other small angle, x plus 41, equals 95. That gives me 2x plus 119 equals 95. Something's up here because I'm going to get negatives. I guess it's okay to have a negative x. It's okay to have a negative x. Let's keep going. 2x equals, what is that, 24, negative 24, and that gives me x equals negative 12, which we can plug in. What does it want us to find? Find x, negative 12. Alright. What is the relationship between a segment bisector and an angle bisector? Segment bisector bisects segment. Angle bisector bisects an angle. When you copy an angle to the lengths of the segments you draw represent the two rays affect whether the angles have the same measure. We're just going to say no. The lengths of the rays don't matter. I'll just show you. Like, that's a 90 degree and that's a 90 degree. The angles are the same. Doesn't matter about how big you draw them. In many protractors, you have two sets of degrees around the edge. When you measure an angle, how do you know which? We're going to talk about this tomorrow. I'm going to stop. That's the last 2 pages. There is another page in there I haven't done yet, so we'll see if I get there.